is the lecture number 16 for the chapter integration, and we are starting with the topic integration by taking limit of sum, which is of a definite integral. That is, if there is an integral whose limit from a to b fx with respect to x, it is equal to limit h goes to 0 h fa plus h plus fa plus 2h up to fa plus n minus 1 into h, limit h goes to 0 here, where n into h is equal to b minus a. This is the formula to find the definite integral by taking limit of sum, and we need this sum of this series, that is 1 plus 2 1 plus 2 plus 3 plus 4 up to n minus 1 is equal to n minus 1 upon 2, 1 square plus 2 square plus 3 square up to n minus 1 ka whole square is equal to n minus 1 n minus 2 and 2n minus 1 upon 6, and 1 cube plus 2 cube plus 3 cube up to n minus 1 ka whole cube is equal to n minus 1 upon 2 ka whole square, and the sum of the geometric series a plus a square up to a r raised to power n minus 1 is equal to a r raised to power n minus 1 upon r minus 1 if r is greater than 0, and it is equal to a 1 minus r raised to power n upon 1 minus r if r less than 0. So this is the formula to find the definite integral by taking limit of sum, and limit h goes to 0 h fa plus h fa plus 2h up to fa plus n minus 1 into h, where n into h is equal to b minus a, and this is the exercise 7.8. Now in question number 1, see it very carefully. It is from 0 to 5 x plus 1 with respect to x, here a is 0, b is 5, therefore nh will be equal to b minus a, that is 1 minus 0, 5 minus 0 is equal to 5, and fx here is x plus 1, and the formula is limit h goes to 0 h fa plus fa plus h plus fa plus 2h up to fa plus n minus 1 into h, where a is 0, so f0 plus h plus f0 plus 2h up to f0 plus n minus 1 into h. Now find f0. Be very careful. Fx is, f0 will be 0 plus 1 1, f0 plus 2h to 2h plus 1, it will be h plus 1, it is 1. 0 plus 1h, so 1 h plus 1, it is h plus 1, 0 plus 2h, so 2h plus 1 up to 1 plus n minus 1, n minus 1 plus n minus 1 into h. When you replace n minus 1 into h, it will be n minus 1 into h plus 1. Now if you are able to find the first two terms, then you can put these terms very easily without calculating the rough. When the first term is 1, then it means in all the terms you will get 1 always, and if the second term is h plus 1, the next term will be obtained by replacing the h by 2h, the next will be obtained by replacing h by 3h, and so on. Now suppose if we have 2h plus 1, then the next term will be 1 plus 4h by replacing h by 2h. So in this you are getting a series as 1 plus 1 plus 1 plus 1 up to n times, and the second series is 1 plus 2h plus 3h up to n minus 1 to h. So you can take h common from it. So when you take h common from it, then it will be 1 plus 2 plus 3 up to n minus 1. When we are having the series of when you're taking h common, then you'll get the series of 1 plus 2 plus 3 plus 4 up to n minus 1. When you take h, when you're getting a h square common, then the series will be 1 square plus 2 square plus 3 square up to n minus 1 ka whole square. When you are having the terms taking common h cube, then the series must be 1 cube plus 2 cube plus 3 cube up to n minus 1 ka whole cube. So 1 plus 1 plus 1 plus 1 up to n times, it will be equal to n, and 1 plus 2 plus 3 up to n minus 1, we have just discussed this formula, it is equal to n minus 1 upon 2. After putting this formula, multiply this bracket with h, so it will be nh, and this will be h square. So you know the value of nh, which is equal to 5, and here you are getting h square. So see it very carefully. We have to use this one h with n and another h with n minus 1. So it will be nh into nh minus h. Be very careful. nh and 1h with this bracket, nh minus h. Put the value of nh, which is 5. It is 5. It is h upon 2 nh. nh is 5, 5, 5. Then you take the limit h 0. So if you put h is equal to 0 here, so 25 upon 2 plus 5, it will be 35 upon 2. So this is the integration by taking limit of sum. Now question number 3 here, it is from 2 to 3 x square. Here a is 2, b is 3, therefore nh will be b minus a, that is 3 minus 2, it is equal to 1. Fx is x square. So formula is fa plus h, fa plus 2h up to fa plus n minus 1 into h. तो A is 2, तो F2 plus H, F2 plus 2H up to F2 plus n minus 1 into H. So F2 will be equal to 2 square, that is 4. F2 plus H, when you find the whole square of 2 plus H, it will be 4 plus 4H plus H square, 2 plus H. When you're getting 4 in the first, the 4 must be there. I just told in the last question also. Or rather you do this calculation F2 plus H in the rough column somewhere and then put. When you obtain this first two term, you can easily find the remaining terms. In the next term, the 4 will be there. The next term will be obtained by replacing H by 2H, which will be 8H. And here, if you replace by 2H, it will be 4H square like this. And so on. The last term will be 4 and 4n minus 1 into H. Before H, it will be n minus 1. And before H square, it will be n minus 1 ka whole square. So you can use this trick to find this series. So you are getting 3 series here. 4 plus 4 plus 4 plus 4 up to n times. One series is obtained by taking 4H common. And the series I've just told you in the last, when you are taking H common, the series will be 1 plus 2 plus 3 plus 4 up to n minus 1. And with this next third series is H square 4H square. When you take H square common, as I told in the last question also, when you're taking H square common, the series you will obtain will be 1 square, 2 square, 3 square up to n minus 1 ka whole square. So 4 plus 4 plus 4 up to n times will be 4n, and the formula for 1 plus 2 plus 3 up to n minus 1 will be n minus 1 upon 2, and the formula for 1 square, 2 square, 3 square up to n minus 1 ka whole square is n minus 1 to n minus 1 upon 6. Now multiply this with h, it will be 4nh, 4h square, h cube. Now I have h square here, so 1h will be used with this n, and 1h will be used this with n minus 1. So it will be nh and nh minus h, h cube. 1h will be used with this, 1h will be used with n minus 1, 1h will be used with 2n minus 1. So it will be nh minus h and 2nh minus h. Now after that, put the value of nh, which is equal to 1 here. So 1, 1, 1, 1, 1, 1. Here like this. Now you take the limit, h goes to 0. So 4 into 1 upon 2, 1, 2 upon 6, h will be 0, h will be 0, limit h goes 0, and you are getting this 19 upon 3. So this is the question number 3 of this exercise. Now in this question number 4, again we have a quadratic polynomial, so be careful in the calculation. Here a, b is equal to 1, b is 4, fx is x square minus x, a is 1, b is 4, and nh will be 4 minus 1, that is 3, fx is equal to x square minus x. So use the formula h, limit h goes to 0, h, fa, a is 1, fa plus h, fa plus 2h, fa plus 3h up to fa plus n minus 1 into h, where a is equal to 1. So f1, so 1 square minus 1, that is 0. f1 plus h, so f1 plus h will be 1 plus h ka whole square minus 1 plus h. This simplify, you will get h square plus h. You take your own time to simplify it. 1 plus h ka whole square minus 1 plus h, h square plus h. This will be term. As I have discussed earlier also, the next term will be replacing h by 2h, it will be 4h square. The next term will be replacing h by 2h, it will be 2h. The next term will be by replacing h by 3h, it will be 9h square. The next term will be replacing h by 3h, it will be 3h. And the last term will be, in place of this will be n minus 1 ka whole square h square, and with this it will be n minus 1 into h. So you can write the last term very easily if you know the first two terms. Now you are getting the two series. One is of h square, taking h square common. This h square, 4h square, 9 square up to n minus 1 ka whole square h square. So one series, when you are taking h square common, so it will be, you will get the series of 1 square, 2 square, 3 square up to n minus 1 ka whole square. As I have already told you in the last questions also, one series is obtained by taking h common, which will be 1 plus 2 plus 3 up to n minus 1. Put the formula 1 square, 2 square, 3 square up to n minus 1 ka whole square, which is equal to n minus 1 to n minus 1 upon 6, and 1 plus 2 plus 3 up to 4 n minus 1, it will be n minus 1 upon 2. Multiply this with h, it will be h cube and h square, because we have h cube here. So 1 h will be use it here with this, 1 h will this bracket, and 1 h with this, it will be nh minus h, 2 nh minus h, and 1 h with this nh minus h upon 2. Replace the value of nh, which is equal to 3. So 3 minus h, 6 minus h, 3 minus h. Now take the limit h goes to 0. So this will be 0, this will be 0, this will be 0. So 3 into 3 into 6 upon 6, which is equal to 9. 3 into 3 upon 2, 9 upon 2, which is 27 upon 2. So there's a fixed method to do these types of questions. In question number 5, we have the exponential series. So see it very carefully. We have a as -1, b as 1. So a is -1, b is 1. So h will be, nh will be b minus a. That is 1 minus 1, that is equal to 2. So use the formula, limit h goes to 0, h, f1 plus h, f1 plus 2h, f1 plus 2h, 1 plus 3h up to f1 plus n minus 1 minus h, where a is -1. So f minus 1 will be, fx is equal to how much? Fx is equal to e की power x. So f1 will be, f minus 1 will be e की power -1. f minus 1 plus h will be e की power -1 plus h. f minus 1 plus 2h will be e की power -1 plus 2h up to e की power -1 plus n minus 1 into h. E will be here like this. Now you are saying that e की power -1 you can take common, e की power -1. So 1 e की power s, e की power 2h up to e की power n minus 1 into h. Now this is the geometric series where a is 1 and the common ratio is e की power h. Sn is equal to a r raised to power n minus 1 upon r minus 1, where a is equal to 1 and r is equal to e की power h. Okay? So a r raised to power n minus 1 upon r minus 1, r is e raised to power h. See it carefully. Now e की power nh minus 1 upon e की power h minus 1. So multiply and divide by h, because we know that limit of e की power x minus 1 upon x, limit x 0 to 0 equal to 1. You know this limit. So that is why to make it equal to 1, so I have multiplied with h divided by h, and this h will be cancelled out with this. So e की power nh is equal to 2. This is 1 and this is equal to 1. So e की power -1 into e की power 2 minus 1 upon 1. So it comes out to be e की power 1 and minus e की power -1. So this is like this, e minus 1 upon e, which is e square minus 1 upon e. That is, in the exponential function you have to use the geometric progression. This is the question number 5 of this exercise, and like this you can do any question based on taking limit of sum. Okay, we'll discuss in the next lecture. Thank you.